Alright, this is our first video in our fraction series, and what we're going to do is we're going to review fractions. Here are the two teaks, and there's maybe some confusing things here, but go ahead and read over it if you'd like. Alright, let's get started. Alright, so we've got this one red piece right here. It represents one whole. A whole cookie, a whole pie, a whole cake, a whole Thanksgiving dinner, whatever. One whole. And then we have these 1/6 pieces right here. And I'm curious, how many 1/6 pieces does it take to equal one whole? So far that's 2, 3, 4, 5, and 6. Because it's on a smartboard, it's a little bit hard to show exactly even, but you can see it takes 6/6 to equal one whole. Now the two parts of a fraction that we have here are the numerator, that's the number on top, and the denominator. The numerator, or rather, let's talk about denominator first. Denominator is how many pieces equal one whole. How many equal one whole? And the numerator is the number I'm counting by. Basically. Alright. So why is the denominator 6? Because it takes 6 pieces to fill that in. Alright. So we've got two more examples here. How many 1/5 would it take to equal a whole? It should be 5. Let's double check that. Say that would be 2, 3, 4, 5. Well, my pieces are over just a little bit, so let's adjust it. Trust me, the answer is supposed to be 5. Anyway, the answer is supposed to be 5. And how many tenths? Well, it should be 10. So 2, 3, 4, 5, 6, 7, 8, 9, 10. It should be 10 as well. There, I'll make it 10. And I can make that 5. There we go. Like I said, it's on a smartboard, so it's not perfect. Alright, so each of these pieces represents a unit fraction. It's called a unit fraction because the numerator is 1. Okay, so unit fraction is when numerator, so say numerator, equals 1. Right? That's what we said right there. So which of these are going to be target fraction, or going to be unit fractions? Again, it's all the ones that have a 1 in the numerator. See, if I do one that doesn't have 1 in the numerator, it doesn't like it. It puts it out. Okay? So unit fractions have a 1 in the numerator. So let's fill in the equation to represent the model. So what we have represented here is, I guess I'll use blue. 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 equals 6/6. So what do you notice about the relationship between the numerator and the denominator in the sum? So in the sum right here, remember sum is the answer. So what happened? They're both the same. So how many 1/3 pieces does it take to equal a whole? I'm not going to do it. We know it's 3. How many 1/8 pieces does it take to equal a whole? The answer is 8. What do you notice about the relationship between the numerator and denominator in each sum? So what they're wanting me to do here is say 1/3 plus 1/3 plus 1/3 equals 3/3. They're the same. And this will equal 8/8, and they'll be the same as well. Because it's 8 pieces of 8. So what other fractions can you write that are also equivalent to one whole? So when we're talking about one whole, the numerator and denominator are the same. 9/9, 50/50, 12/12, etc. Okay, all of those are equal because our numerator is the same as the denominator, and that's 1 whole. So what they want us to do here is label each mark. Now this is a little bit tricky, so I highly recommend going back to this point and rewatching. But I've got this number line right here. I'm going to first count all the tick marks, including 1, but not 0. So start with the first tick mark, 1, 2, 3, 4, 5. And I told you guys I'm going to include 1, 6. How many tick marks? 6. What's our fraction over here? 1/6. So how many pieces should there be? 6. So this represents 1/6. Keep going up all the way to here. 2/6, 3/6, 4/6, 5/6. So remember, 1 whole is the same as 6/6. Numerator and denominator have to be the same. And that's kind of how we count our fractions on a number line. So how many different ways can we decompose 1 whole to represent 6/6? So we have an example here, 1/6 plus 5/6. When you're adding fractions, your denominator always stays the same. You only add the numerator. Because of that fact, your denominator has to be the same in order to do this. So both my denominators are 6, so that's going to stay as 6. 1 plus 5 is 6. Okay, so we could do 2 plus 4. I know 2 plus 4 equals 6. That would equal 6/6. What about 3 plus 3? That equals 6. We already have 4. We already have 5. We could get fancy. We could do 1/6 plus 1/6. That would be 2/6 plus 4/6, and that would still equal 6/6. Okay, so there's a bunch of different ways that we can do this. Oh, excellent. That's my last slide. There's a lot of information here. I highly recommend going back and rewatching this video just to make sure that you understand everything. As always, write down any questions you have on your whisk.